The Chengdu J-20S is an operational twin-seat variant of the Chengdu J-20 Mighty Dragon 5th-generation fighter. Its development was first noted through observations of a prototype undergoing flight testing, with the airframe visually distinct from the single-seat version due to an extended forward fuselage section to accommodate the second crew member. This modification is not merely an addition of a seat but represents a fundamental shift in the aircraft's intended role within the People's Liberation Army Air Force's PLAF combat network. The primary function of the second crew member, often designated as a mission systems officer, is to manage the immense data flow and complex tasking required for networked warfare and the control of unmanned systems. This role is critical in a high-intensity contested environment where the volume of information from the aircraft's own sensors, off-board platforms like other aircraft and satellites, and a team of unmanned combat aerial vehicles would be unmanageable for a single pilot. The division of labor allows the pilot to focus on the tactical flying of the aircraft, threat avoidance, and the final decision to employ its own weapons, while the systems officer manages the broader tactical picture, coordinates with other friendly assets, and directly controls the mission payloads and behaviors of accompanying drones. The development of the J-20S is a direct reflection of the evolving doctrine of manned-unmanned teaming, where a highly capable, stealthy platform acts as a command node for a group of less expensive, attritable unmanned aircraft. This concept, often referred to as collaborative combat aircraft (CCA), maximizes the effectiveness of the manned platform by extending its sensor reach and weapons payload while allowing it to remain at a safer distance from the most intense threat zones. The J-20S is specifically engineered for this role, with its internal avionics and data links configured to facilitate secure, high-bandwidth communication with multiple unmanned systems simultaneously. Regarding its propulsion system, the J-20 program has undergone a phased engine development and integration process. Initial prototypes and early production batches of the single-seat J-20 were powered by the Russian-supplied Saturn AL-31F series engine. Subsequent production models transitioned to the indigenous Shenyang WS-15 engine, which features a different, locally designed nozzle and provides greater thrust and reliability, reducing dependency on foreign suppliers. The ultimate intended powerplant for the J-20 series is the more advanced Xi'an WS-15 engine. The WS-15 is designed to deliver significantly higher thrust, improved fuel efficiency, and enable consistent supercruise, the ability to sustain supersonic flight without the use of fuel-guzzling afterburners. Analysis of recent high-resolution imagery of J-20 airframes, including those identified as J-20S variants, shows engine nozzles with distinct serrated trailing edges, a feature associated with reduced radar and infrared signature. The geometry and appearance of these nozzles differ from both the AL-31 and the WS-10, providing strong visual evidence that the WS-15 is in an advanced stage of flight testing and integration. While it is highly probable that the J-20S is being developed with the WS-15 as its standard engine, it is not confirmed that all current J-20S airframes in the test and evaluation force are equipped with the final, production standard WS-15. Some may still be using the WS-10 as an interim solution. The primary unmanned system designed to operate with the J-20S is the GJ-11, also known by its unofficial name Sharp Sword. The GJ-11 is a low observable, flying-wing unmanned combat aerial vehicle. Its design, evident in photographs from Chinese aerospace exhibitions and satellite imagery from test and operational bases, prioritizes a very low radar cross-section across multiple frequency bands. The airframe lacks vertical stabilizers, and its engine air intake is likely located on the top of the fuselage to minimize its signature from below. It is assessed to have internal payload bays to carry various munitions or sensor packages while maintaining its stealth characteristics. The GJ-11 is designed for penetrating contested airspace to conduct intelligence, surveillance, and reconnaissance (ISR) electronic warfare, or precision strike missions, acting as a forward sensor or shooter for the J-20S. The claim that a J-20S can control up to 6 GJ-11s is a tactical estimate frequently cited in defense analysis circles. This number is not a confirmed, publicly disclosed technical specification from the PLAF. It is derived from modeling of network management capacity, data link bandwidth, and the estimated cognitive load a human operator can manage in a dynamic combat environment. In practice, the number of drones controlled would be a dynamic variable, dependent on mission requirements, the level of autonomy programmed into the drones, and the prevailing electronic warfare conditions. The J-20S would likely issue high-level task-oriented commands to the drone group, such as conduct reconnaissance in this designated sector, form a defensive screen, or engage targets of opportunity within this assigned area. The individual GJ-11s would then use their own onboard autonomous systems to execute these commands, handling low-level tasks like terrain following, obstacle avoidance, and fuel management. This distribution of cognitive labor between the human crew and the artificial intelligence in the drones is what makes controlling multiple assets feasible. For its own organic armament, the J-20S, like the single-seat J-20, is designed to carry its primary weapons in internal base to preserve its stealth profile. The PL-15 is a beyond visual range air-to-air missile. It is characterized by its long range, which is attributed to a dual-pulse rocket motor, and its advanced active electronically scanned array radar seeker, making it a highly capable threat against agile fighter aircraft at considerable distances. The larger PL-17 is an even more specialized weapon, assessed to be an extremely long-range missile. Its primary intended targets are high-value airborne assets such as airborne early warning and control aircraft, aerial refueling tankers, and intelligence-gathering planes. By threatening these support aircraft, the PL-17 can severely degrade the enemy's overall air combat capability and command and control structure. The integration of these missiles allows the J-20S to establish a wide area of air dominance around itself and its accompanying drone team, engaging potential threats before they can close within effective range. The Chengdu J-20S is a purpose-built battle management platform that leverages the stealth and performance of a fifth-generation fighter airframe. Its existence confirms a concrete doctrinal shift within the PLAF towards complex, networked warfare systems. The observable evidence, the physical twin-seat airframes, the concurrent development and deployment of the GJ-11 UCAV, the progression in engine technology visible on test aircraft, and the known integration of advanced long-range missiles, collectively paints a picture of a mature and highly capable system. While the most sensitive details regarding its datalink protocols, the exact level of AI autonomy in the drones, and its maximum effective control capacity remain classified, the J-20S's fundamental role as a force multiplier and a key node in a future aerial kill web is clearly demonstrated by its design and ongoing deployment.